Hello and welcome back to another episode of our sponsored series, In the Spotlight. I'm Jordan O'Brien, Managing Editor of Data Center Review and Electrical Review. Today, I'm pleased to be joined by Shahid Rahman, EMEA Data Center Strategic Account Lead, Engineered IT Cooling Solutions at Mitsubishi Electric. Welcome, Shahid, and thank you so much for taking your time out to talk to us today. As there's only 10 minutes on the clock, shall we get started?
Thank you, Jordan. Thanks for inviting me. Thank you.
First question. Mitsubishi Electric has an extensive history and expertise in the domestic heat pump industry. Can you give us a bit of background on that?
Yeah, sure. Mitsubishi has over 100 years experience in the HVAC industry. And we're committed with innovation, and 5% of our global turnover is dedicated to developing and innovating our products, especially the heat pump side of things. So we have got significant expertise in that technology, commercial applications such as data centers, heat pump systems and renewable networks. And we do offer a wide range as well. So some of the minimal size is 35 kilowatts up to 1.1 megawatt units. And it's always offering a flexible solution for the commercial cooling and heating needs.
How can heat pumps improve the energy efficiency and sustainability of data centers?
That's a good question, Jordan. So I'll just give you a bit of context. So it's not always practical or possible to connect district heat networks onto the heating networks. So, for example, where the local heat requirement is not constant, but there is options for using rejector heat on site. So, for example, simultaneous heating and cooling chillers are particularly useful in data centers with coincidental heating and cooling loads. So if the heat extracted from the areas that require cooling can heat occupied spaces or close to the data center, i.e. the offices, is really good. So this recovered heat can reduce the load of the boilers and supply the heating for the offices, washroom, showers, etc. Other benefits, and if it's a new build or a new project, trying to plan without a gas connection, helping the energy efficiency and sustainability, has to be a question. But in terms of for the data center itself, having a dedicated water source heat pump using the condenser water or alternative water from the data center cooling system as its energy source is a really good approach for large water-cooled chill applications that improves the larger capacity of the chillers, the plant side, returning investment and capital expenditure. So it's really good when you can introduce those technologies.
You touched on a bit there about district heating systems. Can you explain how heat pumps can integrate with district heating systems to provide heating to the local community?
Yeah, that's a very good question and very topical. So historically, UK have not developed any heat networks at the same scale as our Northern European countries.
Yeah.
So, this has made data center connections to networks less likely because of the challenges within regulations. So, but there is increasing optimism and approach to this because of the introduction of the Energy Act, which came into force in October 2023. Basically, it brings heat networks currently unregulated in the UK under the control of Ofgem, which makes heat networks a regulated utility like gas and electricity, which is really good. And also the government has invested over 350 million to scale up low carbon heat network deployments. That includes establishing heat network zones around where UK connections. Another factor making data center connection to heat networks more viable is geography. And London dominates that UK data center sector. And the city is now the largest market in Europe with a capacity over 1 gig. And there's something called the London Plan 2021, which effectively is a sustainable infrastructure development expansion to the district heat networks, bit of a mouthful, where the government is trying to implement. So that's part of the legislation where we're trying to incorporate district heat networks in the city using waste heat sources. So, which is a really good push.
Yeah, absolutely. Are you able to actually tell us any examples of successful data center projects that Mitsubishi Electric has been part of thus far?
Yeah, absolutely, Jordan. So There's a couple of projects that come to mind. So the first one is a project in Ireland, and this particular project, the system is 1.5 kilometers long in terms of networks. It's a pretty sizable heat network. And this will be initially heating 32,800 meters squared of public sector building, while last year, I believe, they added 133 rental apartments to be added to that network as well. And more public buildings will be connected for many years to come, which is brilliant. So ultimately, it reduces pollutant emissions. And this project was in the South Dublin County area. And I think ultimately it reduced the emissions by 1,500 tonnes per year. But the actual system that we incorporate with Mitsubishi Electric partner was we spec'd and with collaboration with our partner with an FOCS2W heat pump, which uses very low GWP refrigerant, which is called HFOR1234ZE. Again, a bit of a mouthful, some of these acronyms. So during normal operations, the heating demand from the network was fully covered by the data center's ejected heat, while peak requests in the winter are satisfied by dedicated heat pumps and a heat pump module supplied by us and with support of our partner. The other one, which is in Finland, which is really interesting, we work with a Finnish energy company called Fortum, and it was capturing the waste heat from a data center by the heat network. The data center has effectively become a heat production plant, with Fortum managing the cooling and heating process, leaving the data center owner Ericsson to focus on its core business, which is really interesting. What Mitsubishi provided with the collaboration with Fortum's is a system is based on two Mitsubishi Electric hydronic and cooling systems, MIHITs, FOCS2W heat pumps, each circa a megawatt of cooling capacity. The unit has the additional benefits of using, again, the low GWP refrigerant, HFO1234ZE, which obviously reduces the equipment's embodied carbon. And heat pumps itself takes heat extracted from the data center, increasing the temperature, boosting the temperature up to 70 degrees C. And this enables Fortum to connect to the data center directly to the district heating system. And the data center, I believe, delivers currently 2,200 gigawatts an hour of heat annually, serving over 7,000 customers to that network. So some really good examples there of demonstrating that capability.
Yeah, it's amazing to see the Scandinavian countries really do seem to be ahead on the heat the heat networks. And actually quite helpful in Finland, since the Helsinki closed its last coal power plant that they were using for heat yesterday. So these sort of solutions are going to be really helpful. Thank you so much for that, Shahid. And thank you for sharing your insights. It was really appreciated. And thank you to everyone who is watching. Obviously, stay tuned for more In the Spotlight videos from both Data Center Review and Electrical Review coming soon. Thank you very much.
Excellent.
Goodbye.
Thank you, Jordan. Thank you.
Bye. Thanks, Shahid.